Hello, I'm going to explain the velocity problem. So this is still in chapter 2, section 1. So this is the problem number 2. Here, the problem is that the displacement in feet of an object moving in a straight line is given by s of t equals 2t squared plus 3t minus 2, where t is measured in seconds. So that's basically the equation of the displacement, a distance equation, right? So the first question is to find the average velocity of each interval. So they give us the interval from 2 to 4, meaning from t seconds to 4 seconds. That's the first interval. The second one is from 2 seconds to 3 seconds. And the other one is from 0 to 2, and then from 1 to 2. Those are the interval in terms of time. So they are all in seconds. So because to find the average velocity, you need two given times, so you can find it. And then the second question, which is a basic question, is to find the instantaneous velocity at the time at t equals 2 seconds. So instantaneous velocity is the velocity at a given time, an instant, a given time. Like here, what was the velocity of the object when time was 2 seconds? Average velocity is the velocity between two times, between 2 seconds, for example, and 4 seconds. What was the average velocity? So part 1 of the solution. So again, the connection between the tangent problem and the velocity problem is that MPQ that we use in the tangent problem corresponds to the average velocity. You can see this equation, the same equation that we dealt with when we discussed the tangent problem. So for the velocity problem, you pick 2 points. So this P is given to us, which is A and S of A, and then you pick an arbitrary point, which is Q, at the point Q, which has coordinate T and S of T, and then you use change in Y over change in X. So S of T minus S of A divided by T minus A. It gives you the average velocity equation. So you can use that to find the average velocity for any given interval. For example, we know A is given to us. You see, this is A, T equals 2, so A is 2. So we can plug in a 2 for A into this equation. Okay. And then you have S of T is given. That's the original equation, S of T. Okay. Now S of A, which is S of 2. So when you evaluate 2 into this equation, you're going to get S of 2 is 12. So the numerator, S of T minus S of A, S of T is a 2t squared plus 3t minus 2 minus, then S of A, which is S of 2, is 12, so minus 12, divided by 2 t minus 2. Okay, so that is going to be equals to this given equation. After you take minus 2 minus 12, it gives you negative 14. So you have this. This is now the equation of the average velocity. So all I have to do now is check every interval. Okay, so you go to every interval and then you check it. So for example, from the interval 2 to 4, okay, 2 seconds to 4 seconds. So what you do is you plug in anything that is not 2, right? Because we already plug in 2 here. So you plug in 4 into this equation, so that it will give you 15 feet per second. That's the average velocity between the time 2 equals 2 seconds and time 2 equals 4 seconds. The next interval, use 3. Okay, so when you plug in 3 into this equation, you get 13 feet per second as your average velocity. And then you go to the interval 0 to 2. So you plug in 0 you get 7 feet per second as your average velocity. Now, when you finish them, so the question B was to find the velocity, or we call instantaneous velocity, at t equals to exactly at 2 seconds. What was the velocity? So that basically, so the instantaneous velocity in terms of the velocity problem corresponds to the slope of the tangent line in terms of the tangent problem. So that's the connection. Slope of tangent line equals to the velocity in velocity problems. So we do the same thing to find the slope m, which is the velocity, which is instantaneous velocity. What we're going to do is basically, okay, so I brought this idea of the limit as t approaches a, but let's just forget that a second. So what we're going to do basically is take the equation of the average velocity. Okay, so let's simplify this. So we take the equation of the average velocity that we already found, which is this. Okay, so take that equation. So take that equation. So this equation, because I did not introduce this idea of limit yet, but so take that equation and then factor the numerator. So if you forget this for a second, you factor the numerator, so you get a t minus 2 times 2t plus 7 over t minus 2. So you can simplify. For t different from 2, you can simplify t minus 2, top and bottom, so to end up with 2t plus 7. So when you get this expression, you're going to evaluate at the given time they're looking for. So at time t equals 2. So you plug in a 2 for t, and that will give you what you're looking for, which is 11 feet per second. That will be your instantaneous velocity. So to simplify this, just take this is the average velocity. When you get it, factor it, and then simplify. And then when you get this term, just plug in a t equals 2, because they ask you to find the instantaneous velocity at time t equals 2. Just plug in a 2 for t, it will give you the velocity, or the instantaneous velocity at t equals 2 seconds, which is, in this case, it's 11 feet per second.